Applying Rectorseal to the threads of rigid metal conduit when the conduit is used to run electrical conductors is a violation of the code. Section 250.110 states that where threaded fittings or nipples are used, they shall be made up tight with threaded joints that are not relied on to establish the electrical continuity between threaded enclosures. The purpose of a threaded joint in an electrical conduit system is to create a mechanically secure connection between the two pieces of conduit. The use of Rectorseal on the threads can reduce the friction between the threads, which can make it difficult to tighten the joint securely. This can lead to a loose connection, which can cause arcing and overheating. In addition, the use of Rectorseal on the threads can interfere with the bonding requirements of the code. Section 250.104 states that electrical equipment and metal raceways shall be electrically connected to ground. This connection shall be made in a manner that will ensure effective electrical continuity. The use of Rectorseal on the threads of a rigid metal conduit connection can make it difficult to achieve effective electrical continuity between the two pieces of conduit. This is because the Rectorseal can act as an insulator, which can prevent the current from flowing through the connection. For these reasons, it is a violation of the code to apply Rectorseal to the threads of rigid metal conduit when the conduit is used to run electrical conductors. The electrical continuity is vital for safety in electrical systems. It ensures that ground faults have a low impedance path back to the source, allowing overcurrent protective devices such as circuit breakers or fuses to quickly operate and clear the fault. This minimizes the risk of electric shock and fire. When Rectorseal is applied to the threads of rigid metal conduit, it can compromise this electrical continuity by creating an insulating layer between the conduit sections. This insulating layer increases the impedance of the ground fault path, potentially delaying the operation of overcurrent protective devices and increasing the risk of electrical hazards. Bonding is also a crucial aspect of electrical safety. It involves connecting all metallic parts of an electrical system together to create a common ground potential. This minimizes voltage differences between these parts, reducing the risk of electric shock. Rectorseal can interfere with bonding by preventing proper metal-to-metal contact between conduit sections. This can lead to voltage differences and increase the risk of electric shock. The National Electrical Code, or NEC, provides specific requirements for grounding and bonding to ensure electrical safety. These requirements are based on established engineering principles and best practices. Compliance with the NEC is essential for protecting people and property from electrical hazards. The NEC addresses the use of threaded fittings and nipples in Section 250.110, emphasizing the need for tight joints to establish electrical continuity. This requirement reflects the importance of maintaining a reliable ground fault path. The code also specifies requirements for bonding metal raceways in Section 250.104a, ensuring that they are effectively connected to ground. These requirements are intended to minimize voltage differences and reduce the risk of electric shock. The use of sealants and lubricants on conduit threads can have both positive and negative effects. On the one hand, they can help to create a watertight seal, protecting the electrical conductors from moisture and corrosion. On the other hand, they can interfere with electrical continuity and bonding, compromising safety. Therefore, it is important to choose sealants and lubricants carefully and to apply them in accordance with the manufacturer's instructions. It is also important to test the electrical continuity of the conduit system after installation to ensure that it meets the requirements of the NEC. There are several alternatives to using Rectorseal on conduit threads. One option is to use a sealant or lubricant that is specifically designed for electrical applications. These products are formulated to provide both a watertight seal and good electrical conductivity. Another option is to use a thread-cutting oil or compound when threading the conduit. These products can help to create a tight, secure joint without the need for additional sealants or lubricants. It is also possible to use thread seal tape, also known as Teflon tape, on conduit threads. However, it is important to use a tape that is specifically designed for electrical applications and to apply it carefully to avoid interfering with electrical continuity. Proper installation techniques are essential for ensuring the safety and reliability of electrical conduit systems. These techniques include using the correct tools and materials, tightening connections properly, and testing the system after installation. It is also important to follow the manufacturer's instructions for all products used in the installation. Proper installation techniques can help to prevent loose connections, arcing, overheating, and other electrical hazards. In addition to following the NEC and using proper installation techniques, it is important to have a thorough understanding of electrical theory and safety principles. This knowledge can help to identify potential hazards and to take appropriate precautions. Electrical work should only be performed by qualified and experienced individuals who are familiar with the relevant codes and standards. When working with electrical systems, it is important to always de-energize the circuit before starting any work. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to use appropriate personal protective equipment, such as gloves and safety glasses, to protect against electrical shock and other hazards. Regular inspection and maintenance of electrical systems are essential for preventing electrical hazards. These inspections should be performed by qualified and experienced individuals who are familiar with the relevant codes and standards. Maintenance tasks may include tightening connections, replacing damaged components, and testing the system to ensure that it is operating properly. By following these safety precautions, it is possible to minimize the risk of electrical hazards and to ensure the safety of people and property. Understanding the implications of using substances like Rectorseal on electrical conduit systems is a key aspect of responsible electrical work. Always prioritize safety and adherence to the National Electrical Code to prevent potential hazards. When in doubt, consult with a qualified electrical inspector or engineer to ensure that your installation meets all applicable requirements. Consider the specific environment in which the conduit is installed. In outdoor installations, weather-tight connections are crucial to prevent moisture from entering the system. However, remember that achieving a weather-tight seal should not compromise electrical continuity and bonding. Select appropriate materials and methods that address both needs. When choosing sealants or lubricants for electrical conduit, look for products that are specifically listed or labeled for electrical use. These products are designed to provide both a seal and electrical conductivity, minimizing the risk of compromising safety. Read the product data sheets and application instructions carefully to ensure proper use. The NEC provides detailed requirements for grounding and bonding in Article 250. Familiarize yourself with these requirements and ensure that your installation complies with them. Pay close attention to the requirements for connecting metal raceways to ground and for bonding metal parts of the electrical system together. The NEC is updated regularly to reflect changes in technology and best practices. Stay current with the latest edition of the NEC to ensure that your electrical work meets the most up-to-date safety standards. Consider attending training courses and seminars to enhance your knowledge of electrical codes and standards. Electrical safety is a shared responsibility. By understanding the risks involved and taking appropriate precautions, we can all help to prevent electrical hazards and protect people and property. Remember that electrical work can be dangerous, and it should only be performed by qualified and experienced individuals. If you are not comfortable performing electrical work yourself, hire a licensed electrician to do the job. They have the knowledge, skills, and experience to perform the work safely and in compliance with all applicable codes and standards. Grounding and bonding are not just theoretical concepts, they are essential for protecting people from electrical shock and preventing fires. By ensuring that electrical systems are properly grounded and bonded, we can create a safer environment for everyone. Effective grounding and bonding provide a low impedance path for fault current to flow back to the source, allowing overcurrent protective devices to quickly trip and clear the fault. This minimizes the duration of the fault and reduces the amount of energy released, preventing damage to equipment and reducing the risk of electrical shock. In addition to providing a path for fault current, grounding and bonding also help to minimize voltage differences between metal parts of the electrical system. This reduces the risk of electric shock if someone comes into contact with two different metal parts. Voltage differences can occur due to inductive coupling, capacitive coupling, or ground faults. Proper grounding and bonding help to equalize the voltage potential, minimizing the risk of shock. Regularly inspect and test grounding and bonding connections to ensure that they are in good condition and providing a low impedance path. Look for signs of corrosion, loose connections, or damage to grounding conductors. Use a low resistance ohmmeter to measure the impedance of grounding and bonding connections. High impedance indicates a problem that needs to be addressed. When making grounding and bonding connections, use appropriate connectors and hardware that are listed for the purpose. Ensure that connections are clean and tight to provide a low impedance path. Avoid using dissimilar metals in grounding and bonding connections, as this can lead to corrosion. Clearly label all grounding and bonding conductors and connections to facilitate inspection and maintenance. Use green insulation or green tape to identify grounding conductors. Use bonding jumpers to connect metal parts of the electrical system together. Bonding jumpers should be sized according to the requirements of the NEC. Proper grounding and bonding are essential for the safe and reliable operation of electrical systems. By following the requirements of the NEC and using good installation practices, we can minimize the risk of electrical hazards and protect people and property. If you have any questions or concerns about grounding and bonding, consult with a qualified electrical inspector or engineer. They can provide guidance and ensure that your installation meets all applicable requirements. Always prioritize safety when working with electrical systems. Take the time to understand the risks involved and to follow the appropriate safety precautions. Electrical work can be dangerous, but by being careful and knowledgeable, we can minimize the risk of accident. Effective communication is key to ensuring electrical safety. Make sure that everyone working on or around electrical systems is aware of the potential hazards and the safety precautions that should be taken. Hold regular safety meetings to discuss electrical safety issues and to review safety procedures. Encourage workers to report any potential hazards or unsafe conditions. A proactive approach to electrical safety is essential for preventing accidents and injuries. By identifying potential hazards before they cause problems, we can take steps to mitigate the risks and protect people and property. Perform regular hazard assessments to identify potential electrical hazards in the workplace. Develop and implement safety procedures to address these hazards. Provide workers with training on electrical safety and hazard awareness. Encourage workers to actively participate in the safety process. A culture of safety is essential for creating a safe and healthy work environment. By promoting safety at all levels of the organization, we can reduce the risk of accidents and injuries and improve the overall well-being of workers. Lead by example and demonstrate a commitment to safety. Recognize and reward workers for safe behavior. Continuously improve the safety process by soliciting feedback and making adjustments as needed. Remember that electrical safety is an ongoing process that requires constant vigilance and attention. By staying informed, following safety precautions, and promoting a culture of safety, we can minimize the risk of electrical hazards and protect people and property.